All right, number 13, it says among the triangle below are multiple pairs of similar triangles. When it says that, like, there are multiple answers, I think, for A. For B, there's only one option, but for A, you could literally have different pairs and still be right. So when we do A, it says find a pair of triangles similar by AA, similarity, create a flowchart. I'm just picking one of the options, but you can have different ones. So like, for example, these ones could be similar because you have 1, 2 sets equal, and then, but you also could do, like, these ones are similar because you have 2, you have a third there, but there's no information, so it's not a big deal, you can use it. So you got lots of options, but I'm gonna just do the last 2. So the last 2, if you're doing AA, you know you're starting with 2 bubbles because you have 2 letters. And remember, those letters represent pairs of things, not just one item. So the first A, you're going to talk about the first pair of angles. So I'm going to just pick a pair there. And I'm going to say the measure of angle A equals the measure of angle M. In my classes, remember, my students, we say for angles, we put letters in our bubbles. And then for sides, we put numbers. So it's just kind of a reminder for ourselves to do that. And then the other set of angles are going to be B and N. Just a quick reminder, if you've struggled with this, when you don't have numbers on the angles and you have markings, like, for example, this marking or this marking, when you have those markings, when they are the same, that means they're equal to each other. We don't know what the numbers are, but we know that they're equivalent. So that's why we were allowed to match up A and M, and also we're allowed to match up measure of angle B equals measure of angle N. So then you want arrows. This is a flow chart. It is not just a chart. We need to know the flow of information, so you need arrows. Drawing just a line like this does not tell me which direction you are telling me things are going, so you're just giving me a chart. So remember, you want to show the flow. So then we're going to write the similarity statement. Just another reminder, when you are doing flowcharts, you will never write just a similar symbol up here anywhere. Never. You can write a congruent symbol, which is this. That could come up in the above part. For example, you could write angle A is congruent to angle M if you like that better than measure of angle A is equal to measure of angle M. But you will never, ever, ever, ever write a similar symbol up there. You will always write similar symbols down here along with a similarity. See how that symbol comes up here and here? That will happen every time. So then we are going to match things up. The first triangle, it doesn't matter what you write for your similarity statement, so I'm just going to pick an order, A, B, C. And then the second triangle has to follow the order of the first. So A has to go with M, so that's first. B has to go with N, so that's second. And the reason why I'm saying they have to go together is because they correspond to each other. If I were to do a transformation, so rotation, reflection, translation, dilation, if I were to do those things, I need them to go right back on top of each other, exactly the way they're supposed to, and that would be putting those letters together. So like A goes with M because of their markings, so that's how I know they go together. All right, M and O, last letter. Okay, so now let's look at side angle side. Find a pair of triangles similar by side angle side. So there's only one set you can use here. Looking at this, these are the only ones that have any sides on them, so we got to use them. And conveniently, they are side angle side. Let me move that a little bit. It's kind of hard to see here. There we go. So let's get our bubbles set up. We have 3 letters, so we're going to start with 3 bubbles. And then those 3 bubbles are going to lead to a bubble. I always love making these little templates. I think sometimes these questions can be a little confusing, but if you get yourself set up, then you've got places to put things. And then the last part, I'm going to just already put side angle side similarity down here. Okay, so let's go back up. Let's just pick one set of sides. So I know this is small and big. So I want to match up accordingly with small and big in the other. You don't have to use those little circles and squares and stuff like I do, but I think it's just easier for me to organize my work. So 9 is small, so I'm going to put a square around it. Or, oh, I'm going to put a circle. Obviously, I'm not organized, I guess. And then 15 is big, so I'm going to put a square. So 6 and 9 go together. So I'm going to do 9 over 6. And then I want to figure out what that is. What we're doing right now is seeing how the triangle sides are growing and if they're growing at the same rate. So currently they're growing at 1.5 for that set. The goal is to make sure they grow at the same rate for the other set. So the other set is 15 and 10. So I am going to keep the same order as I did before. So I did 9 first, so I'm going to do 15 first. So 15 over 10 is also 1.5. So they are growing at the same rate. We're good to continue. If they were not growing at the same rate, that would tell you that they're not similar. You would stop and you would explain, these are not similar because the sides aren't proportional. They don't grow at the same rate. So many different things you could say there. Okay, so just as a reminder, the picture has to follow side angle side, but when you're writing your stuff down in the bubbles, that does not have to follow that. So the last bubble has to be angles, and we know angles have to have letters inside them. So measure of angle blank is equal to measure of angle blank. So when I go back up, the angle has to be in between the two sides. We do have other angles that are equal here. Well, no, we don't. H is not equal to D because they have different markings, if you can see that. So we do have our angles here in between the sides. That's the ones we want to talk about. So I need to erase a little bit because I can't see anything. E and I are the ones we want. So angle E is equal to angle I. So then I'm going to write our similarity statement, just picking random order for the first one, GHI. Not taking too much time on that, doesn't matter. But then the second one, we do want to make sure we take time on it. So G, I keep moving. G to H. So we do need to be careful because G to H could represent D to F or F to D because nope, just kidding. G to H has to be D to F. The reason for that is these are not equal, so they can't match up in when we're writing things out. Another way you can think about it is going from G to H. I'm going from the short side to the long side, so then I need to again go from short to long, and I did. So D, F, and then E is your last letter. All right, and then the last here, I'll move this out so you can see it all together. And you can pause it if you need to. All right, last one. It says find the values of x and y if needed, round to the nearest thousandth, 3 decimal places. So let's start with finding x. X is in a right triangle, and we've got two sides of that right triangle, so we can do Pythagorean Theorem. So we don't even have to look at the other triangle yet. So x squared plus 12 squared equals 16 squared. All right, so we need to talk about this, the elephant in the room. A lot of people want to make the variable the c part of a squared plus b squared equals c squared. The c has to be the hypotenuse, so longest side, side across from 90, however you need to think about it, the slanted side. There's a lot of different routes of thinking of what it is, but it has to be that. So this equation is different than when we were doing it here because the hypotenuse was the variable for both of these. But now in this question, there is a number on it, so it looks a little different. So because it looks different, we're going to end up doing things differently in the equation. So we're still writing out everything squared. So 12 squared is 144, 16 squared is 256, and then instead of where we were adding these together before, because the numbers were right next to each other, they're not, so we just solve minus 144, just as you normally would with any algebraic equation like that. So 256 minus 144, x squared equals 112, and then you're going to take the square root of both sides, and you get x is about 10.583. Sorry, that's an 8. So that is this part right here, 10.583. And then we're going to find the other piece. So we've got y, we've got 12 corresponds to it, and then 36 and 16 correspond. We know that these two triangles are similar by angle. So we can write a proportion because the sides are growing at the same rate because they're similar. So we do not need a flowchart to say this because we know they're similar. We're going to use a proportion to help us solve for missing pieces in the similar triangle. So 12 over y should equal 16 over 36. They should grow in the same way, so those fractions should be equal at the end. So now we're going to cross multiply to solve. So 12 times 36 equals 16 times y. So 12 times 36 is 432. And then 16y. We're going to divide both sides by 16 to solve for y. Y equals 27.